Hello. Someone in chat tell me if the microphone is working properly. Welcome to 3200. Hey Critch, is that Lucas? I have an echo. Anyone else hearing an echo? Is it like a room echo, or are you hearing my voice twice? Not much I can do about the room echo. Awesome. Well, hopefully this works out. Hopefully we don't have too many trolls in the chat. Looks like we have about half the numbers of the class here. For anyone who's interested in the statistics, we have 117 people total for this course, which is crazy. So let me tell you a little bit about the course. So this is Computer Science 3200. Algorithmic Techniques for Artificial Intelligence. So it's sort of an intro to AI class. At the same time, we're also running Computer Science 6980, and 6980 is essentially the grad version of the course. So we'll be doing one set of lectures for both the undergrad version and the graduate version of the course. And what's going to happen is the graduate version of the course is going to have an extra project, and every assignment will also have extra things that they have to do in the assignment. So, first of all, for any of you who are homesick, I've prepared something for you. So in case you want to be in the lab, we can be in the lab while we're doing this. So I went in there and hacked the lab, and we can talk in the lab for a bit if you want. So I'm going to try and keep up with a little bit of the chat just for this lecture. We don't have... While I'm giving lectures, actually giving the PowerPoint presentation, it's kind of hard to keep up with the chat, but what I'm going to do is every, I don't know, 5 minutes or so, I'll go back and I'll read some of the chat and hopefully answer some of the questions and try and keep up that way. If not, then I can stick around after the lecture and give some of the, or answer some of the questions that way. So yeah, this is the lab. Let's see what I can do here. Can I hack this some more? Hang on. There we go. I'm hacking. No, that's it. Can't hack the lab anymore. So we'll just go with this for now. All right, so I'll go over the first thing I'll go over is the syllabus for the course. So you've already seen this. It's on the website. Nothing has changed with the PDF, but I'll just go over it for both courses because it's important to do that. And then I'll have some PowerPoint stuff for today. Just go over a brief introduction of like what artificial intelligence is and sort of more what you can expect from the course. Welcome to anyone who might not be in the actual course itself. You're free to watch the lectures, but the course materials like the assignments and stuff, they won't be given out to non-students. Also, for people in the class, in case you didn't see the D2L post, we have a Discord server, but please don't give out the Discord server link on the Twitch chat or anywhere in public because we want to keep that just to the class. And also, don't give out the password to the homepage because I'd prefer that the assignment files and stuff just say within the class. So here I have the PDF for the course. You can see all my information on my website. Kind of prefer to use my Gmail email address. Oops. If you are going to email me, so I'll probably respond faster if you use the email. My office is not going to be used this term, so just ignore that. And office hours, just essentially message me on Discord or send me an email and we can meet up somewhere. Because I don't have like scheduled office hours this term. Here's the course website. You can go to the course website. Just let me load it up over on the other monitor here. So here, if you see, I know sometimes the font can be pretty small. If you go to the website, you type in the username and password, and then it's pretty basic, right? We've got an assignments directory. This is where all the assignments will be posted, so you can just download them from here. There'll be a zip file for like COMP3200 A1, A2, A3, all the way up to A5. In here, I'll post all the lecture slides, so the video recording of this will be posted, but also the lecture slides will be posted. So you can have the actual PDF if you want to read through them themselves and don't want to watch my webcam or something like that. Also, we have the course outlines that are here that you can download, and that's what we'll look through now. So here's the syllabus. I'll just read out the course objectives. So this course is an introduction to artificial intelligence, or AI, covering algorithmic techniques and data structures used in modern problem-solving environments. Each topic will have a related assignment where the learned techniques are applied to simple games. And I'm talking really simple games. We're not going to be going to like Mario or anything like that, but it'll be a nice application that is sort of modern with a GUI and stuff. So what are we going to learn in the course? First, we're going to do an intro to AI. So we'll have like, what is AI? What can modern AI do? Games as a testing environment for AI, agents, environments, and problems. So the beginning of the course is really like a lot of definitions and terminology that we have to just get through in order to carry on with the course, right? So you have to know these terms in order to be able to apply stuff later. Then we're going to talk about search algorithms. So this will be pretty much the first half of the course will be search algorithms. And so we'll first go into things like exhaustive search, so breadth first search and depth first search. And I know that some of you have probably taken courses before where you've done things like BFS and DFS, but I'm going to introduce a really unified algorithm that will go through all of our search algorithms and create like a really nice narrative through the search algorithms. And so I promise that this will be something new, and hopefully it will help to solidify that in your mind. And we'll really go over why all of these search algorithms are really, really similar to each other. Then we'll go into heuristic functions and incorporating knowledge into search. So rather than just complete exhaustive search, how can we take knowledge about the problem and incorporate that into the search to make the search faster? Then we'll get into heuristic search, where we talk about things like best first search and A star. And that'll be assignment 2. So I'll go over the assignments in a bit. But assignment 1 is going to be exhaustive search, so breadth first search and depth first search. Assignment 2 is going to be A-star search, and assignment 2 is probably by far the most work. So look forward to assignment 2. Then we'll go over an introduction to game theory, so not like a really deep dive into it, but we'll do some game theory. We'll play a couple of games in the chat. I'll put some polls up. We'll talk about things like Nash equilibria, and once we have this theory down, then we'll get into adversarial search. So adversarial search is search, but you're playing against an adversary. So up here where we talked about heuristic search and exhaustive search, we're talking about what's called single agent search. So this is something, single agent search is where you have like someone trying to escape from a maze, for example. But adversarial search is talking about algorithms such as minimax, alpha-beta pruning, where you might be playing checkers or chess against another opponent. And so assignment 3 will be on this, so you'll be doing alpha-beta search to create an AI to play a game. And we'll also talk about different data structures and optimizations for search that you can do things like, instead of linearly scanning an array or something, how could we make that log n, or maybe even constant time lookups for some things. Then we'll go into a little bit about genetic algorithms, so 2 or 3 lectures about GAs. We'll give an introduction to evolutionary algorithms. We'll talk about the representations that are used for genetic algorithms, so the data types for like the genotype and the phenotype. We'll talk about implementing genetic algorithms, so mutation, crossover, selection, reproduction, and then we'll have a assignment about genetic algorithms. Well, you will write a genetic algorithm to solve Sudoku puzzles. So that'll be assignment 4. So if you've heard about the course from previous years, genetic algorithms were not in the course in previous years. And so I'm actually introducing that back into the course from when this course used to be like 4752. And if you've done the biologically inspired or nature-inspired computing course, then this is a part of that course, so you should have an easy time with that. The last sort of third of the course will be mostly on reinforcement learning. So we'll go into, we'll have an introduction to reinforcement learning. So what are agents, environments, actions, policies, and rewards? And then we'll talk about bandit problems, so exploration versus exploitation, and how do we solve those sort of problems. We'll talk about MDPs, so Markov decision processes, generalized policy iteration, which is sort of the way that reinforcement learning works. Then we'll talk about Monte Carlo methods for reinforcement learning. And then finally, we're going to end the reinforcement learning with temporal difference learning. So we'll talk about SARSA and Q-learning, and we'll only be talking about tabular reinforcement learning in this course. So you can go on to deep neural nets and deep learning, deep reinforcement learning later with a bunch of grad courses in that if you want, but we'll stop just short of that in this course. And we'll give sort of the introduction to reinforcement learning. So you'll be able to hand code a reinforcement learning algorithm from scratch, which should be pretty fun. And then right at the end, we're going to talk a little bit about neural networks, because you can't really have an AI course without neural nets. And so we'll talk about artificial neurons, the neural net structure, the training, how you would program a neural net, and then we'll give like a really brief introduction to deep learning at the end of the course. And so if you've been keeping up with the news of AI, or if you're looking at, the general media talking about AI, they would have you believe that this is like all of AI, right? Modern AI is all neural nets, right? Well, there's a lot of neural nets in modern AI research, but they're not going to be a big part of this course. They are more in the nature-inspired computing course, as well as the machine learning course. So if you want a course that is strictly machine learning, where all you're doing is learning about machine learning, then there is a course for that. I can't remember the name. If someone has taken that course or knows the number for the machine learning course, you can just type that in the chat if you want. So all of the topics are going to be the same for the 3200 course as well as the 6980 course. Okay, so 3202 is Intro to Machine Learning. So this course is not a lot of machine learning, because we have another course that's completely dedicated to machine learning. So When it comes to textbooks, I've tried to design this course specifically so that the textbooks are not required, but they will help you. So there's one textbook, Artificial Intelligence, A Modern Approach. It's kind of an expensive textbook. The first half of the course that's on search is modeled after the way that it's presented in this textbook. And so if you get the Russell and Norvig version of AI, the textbook, then you can follow along with that. And of course, studying that will help you, but it won't be necessary for the course. In the second half of the course, when we do reinforcement learning, this is the best textbook that I've ever read. It's the only textbook I've ever read from start to finish, and it will really help you with reinforcement learning, and especially the second part of the course, and it's online for free, okay? So that is here. You can just click on that. There's a PDF, there's an HTML version with a table of contents. It's really awesome. I was lucky enough, so Rich Sutton, who is basically the grandfather of reinforcement learning, I actually got to take the reinforcement learning course from him at the University of Alberta, and that was really awesome. So this book is great. I recommend reading it. You could even get started reading a little bit of it before we start. So the format of the course, you're here, so you kind of know the format. We're going to have 2 lectures every week. We're going to have them on Tuesday and Thursday. So 10:30 to 11:45 is the time slot for 3200. I'm also teaching another course, which is 4300, which is the intro to game programming course. If you're in the chat and you're taking both courses, can you just type so in the chat? I'm curious how many people are taking both courses with me this term. And after each lecture, I'm going to stick around. All right, so we've got a few people taking both. That's cool. After each lecture, I'll stay on the webcam for a while and just answer any questions that anyone has. And so we can do that. And hopefully we won't have to have too many out-of-class meetings. But of course, if you're on Discord, you can ask me questions at any time and we can pop in a voice chat, etc. So here's what you probably care about. How do you get marked for this course? So there is a lot of programming in this course. My opinion about CS coursework is that you don't really understand it until you've implemented it. And so that's really sort of the motto of this course. So you're going to be implementing pretty much everything in this course from scratch. So the first assignment is going to be sort of the introduction to JavaScript. So this course is the implementation is in JavaScript. And you might say, oh, why would you do it in JavaScript? It's so weird. Well, JavaScript, the language, I'm not a huge fan of, but the programming principles and the actual programming techniques we're going to be using are pretty basic. Like, all you're going to need to know in terms of programming in this course, besides so we're going to learn the algorithms, but the programming techniques that you have to learn, you're going to need to know in JavaScript how to make an array, how to make a 2D array or an array of arrays. You're going to need to know for loops, basic variables, classes, and that's it. Okay? So we don't need we don't need C++ for this course. And what JavaScript does allow us to do is make really cool visualizations. So here's an example. This is on my course right now. This is on my website right now. And this is the type of thing that we'll actually be doing for the course. So we have these user interfaces where we can search for the shortest path between 2 points in a map, and we can do really cool animations that actually show how the search algorithm is working in real time. And the great thing about this is you don't need to install any IDE because it's just JavaScript, right? So as long as you have a browser, you can run this code. So you need a text editor to open the JavaScript file, and you need a browser to open the HTML file. And that's all you're going to need for this course. And so you can do that on any operating system, on any computer, and you'll be good to go. So if you go to my website /search, you can play around with this. So these are the type of, this is what we're using JavaScript for in this course. It's the fact that we can do lots of cool visualizations, and it'll help with debugging and lots of interesting stuff like that. So that's why we're using JavaScript. So the first assignment is going to be getting you familiarized or learning a little bit of JavaScript, and it's going to be breadth first search and depth first search for that assignment. The second one is going to be A-star pathfinding, and that's going to be the most involved assignment. It's probably going to be the most amount of work. We're going to do lots of search optimizations there, and so you can spend as many hours as you want on that assignment. The third one will be Minimax plus Alpha Beta for playing a game. We're probably going to stick with Connect 4 as the game because it's a really simple game. It's really easy to debug, and the thing about Minimax and Alpha Beta is that it can be a real pain, especially if you're not familiar with recursive programming, like recursion and recursive algorithms. That can be a real... it can really be something to get your head around, so we're going to stick with a simple game for that one. The fourth one will be on a genetic algorithm. So a genetic algorithm to solve a Sudoku puzzle is what I'm going to do there. If you don't know what Sudoku is, you can go look that up. And the fifth assignment will be on reinforcement learning, and we'll be implementing Q-learning to solve a pathfinding problem. So a lot of the assignments sort of have the same goal. There's a theme here. There's a lot of like search and pathfinding. And the reason for that is that I wanted you to see sort of the pros and cons in using different algorithms to solve the same type of problem. So these 5 assignments will be worth 50% of the course, and they will not be weighted the same. Okay, so for example, this intro assignment might be worth between 6 or 8% of the course because it's not a big assignment. This one might be 12 or 14%. I don't have the exact marking scheme down, but like assignment 2 might be worth twice what assignment 1 is worth. And the important thing for this course is that we will be working in groups of up to 2. Okay, so I have designed the assignments such that it's like 1.5 persons worth of work. So you can choose to do the assignment solo if you want, but I would not recommend it, okay? So what I'm going to do is in Discord, please, you can post that you want a partner for your assignments, and you can give your email, whatever, and we can find partners that way. If you know someone in the course, you can choose your partner. If by like the beginning or first or second day of the first assignment, if you still don't have a partner yet, I can get all the names of people who don't have partners and randomly pair them up and send them an email. Okay? So find a partner for the assignments. I strongly recommend doing that. Some people said in the questionnaire that I sent out that they don't like group work. Well, if you don't like group work, you're in the wrong profession, because once you graduate, everything you do will be in teams of people, okay? So I will be literally spending almost an entire class explaining each of the assignments, so you don't have to worry about not knowing what the assignments are. And for each assignment, there's a detailed marking scheme for each assignment, and I'll show examples of that when we get to the first assignment. So yeah, please find a group for that. In this course, we are going to have a midterm and we're going to have a final. So in previous iterations of this course, there has been a final project on top of the final exam, but because we're online this term, I don't want to like bog down the undergrads too much. So we'll have a final exam and a midterm, but we will not have a project, okay? The grad version of the course, so 6980, will have a project, okay? So the weighting of the exams for the grad students is a little bit less, but we will have a project as well. So the project for the grad students is going to be less than or equal to 2 per group as well. I just made a typo here, so I'll fix that. So don't worry about it. Now, here's the thing about this course. A bunch of people sent me that they were worried about this, okay? So just let me read it out. So due to the group nature of this course, to effectively show that you've individually learned the material, you must pass the final exam to pass the course. If your grade on the final is less than 50%, then your overall course grade will be equal to the mark that you received on the final exam. If your final exam grade is greater than or equal to 50%, then your course grade is determined by the scheme above. And what that means is, If you get a 10% on the final exam, then your mark in the course is 10%, okay? And that's because it's the entire assignments. Like, if you get 100 on all the assignments, you're already passing the course, right? And believe it or not, if you can believe this, some people get carried through the assignments, right? So you might have groups where one person does a lot of the work and one person didn't even learn the algorithms, right? I've had that actually happen in the course before, and that's not the point of the course. But don't be too worried about this, because in the 4 years that I've been teaching this material, this rule would have only applied to one person, okay? So in the hundreds and hundreds of people who've taken the course, only one person has ever failed the final who has been passing the course up to that point, okay? So the final exam, don't worry about it too much. And it's not like if you get a 40, I'm just automatically going to fail you. We can do other things like maybe to catch you up to that 50, or do like some sort of extra work to catch you up there. So don't be too scared about that. It's just there to make sure that people who are going into the final with a passing grade already have some sort of motivation to actually learn the material to study for the final. Also, any questions that you have about this, you can type it into the chat. So someone said, will you be providing a rubric for each assignment? Yeah, so each assignment will have a very detailed marking scheme. And you'll know before you have, like, the marking scheme is so detailed that you'll know. So the syllabus isn't on D2L, the syllabus is on the website. So that, yeah, I forgot to edit that. If you go to the website here, okay, so there's a link to the website, it's in Syllabus, okay? And then you click on the PDF files here for the syllabus. How will the exams be proctored, if at all? The exams will not be proctored, okay? But that means they will be open book. But because they're open book, they will be a little bit harder than they have been in previous years, okay? So we'll be using like the online quiz. I will not be proctoring exams. I won't be looking at you. But there will be a pretty tight time constraint on them, right? So we have to test you somehow, and the questions that I will be asking, don't PogChamp at open book, because I will be asking questions where the answers are not in the notes, okay? So you will not be able to look at the notes to answer the questions. You will have to actually type in a long answer that shows that you have like the actual knowledge of the course. Will there be programming section on exams? There may be. I might ask you for pseudocode for algorithms on exams, but you will not have to write like actual code that compiles. Do we need to complete all the assignments by JavaScript? Yes, you will have to complete all of them by JavaScript, because the assignments will be given out as, we'll get into this, but essentially every assignment will come with a graphical user interface, okay? The GUI will already be done for you. So you can interact with it with the mouse. I am handing out this. So the assignments are like a framework, and you have an API into that framework. And you're going to be writing the algorithmic backend for that. And it'll all be really obvious what I'm talking about when I actually get into the assignments. But you can only do the assignments via JavaScript in the exact format that I've given you. So if you thought that previous classes were like really pedantic about semantics and syntax and stuff, you haven't seen anything yet. This is real computer science, right? I've given you an exact format that you have to fill out, and if it doesn't work, then you don't get the marks, right? And you'll see why that works when I get into the first assignment. I'm not going to do that on the first class, but trust me when I say that it works, and people have fun with the assignments, and I've gotten really good feedback about that. So you have to use JavaScript, even if you don't like it. Sorry. So I got another question here. Can we use GitHub to collaborate? Yes. So this is very, very important. I have found solutions online to these courses in the past. So that is not allowed. Okay, these assignments are copyrighted. We can go after you legally if we have to in order to get these taken down. Okay, so obviously no cheating. you can use GitHub to collaborate, but it has to be a private GitHub repo, okay? I regularly troll GitHub for, like, I have scripts set up to look at public GitHub repos and see if any of my code is in them. So please do not use public GitHub repositories or we'll come after you. And just ask previous courses. I actually care about this stuff. So I'm not just like send it out and then not care about it. I really care about this, and I care about you guys doing this yourself. So please do not post public solutions, public code anywhere. By all means, you can use the Discord to like ask questions about the assignment. Like if anyone has a clarification about a question on an assignment, you can post in Discord, as long as you're not actually posting like solutions to the assignment, right? So you could say, oh, where is the code in the, like I know he posted code in the lecture notes for this, where is that? And so, you know, you can answer other people's questions if you want. How much time do we have for each assignment? Except for the first assignment, you will have at least 2 weeks to complete each assignment, okay? But those 2 weeks, like, I don't want to say you absolutely can't do this stuff the night before, but you probably can't do this stuff the night before, right? It takes me a couple of hours to do these assignments. And so if you've never seen the material before, it's going to take a while. Like, these are not easy assignments, but the good part is you're going to learn a lot from these assignments, okay? And by the way, if you see me looking in this direction, that's me reading the chat. So the assignments are very important. The assignments are really sort of the meat of this course, and it's the implementation of that. But also, I want you to know the theory and be able to answer those questions for the midterm and the final, okay? So, yeah, currently 103 viewers. How many are in the course? So there are about 90 undergrads and 30 grads. So about 120 in the course. And of course, here's the the fine print that you should read as well about all that kind of stuff. Now, another really important thing is that because this course is entirely online, we will be very strict on cheating and plagiarism. And I cannot stress that enough, okay? I know that there are some profs out there who don't read the code, and you can go to Wikipedia, and you can copy and paste solutions, and you can copy each other's assignments. We have all the code from all the previous year's assignments. We can run diff on your assignment and the previous year's solutions really easily and see if you've copied and pasted other people's code. I have put special Unicode characters in the assignments. Okay, so if you copy and paste stuff from previous year's assignments, there'll be characters in there you can't see that we can, that shows, like, I'm not joking around about this, okay? Do not cheat. You will have zero benefit to cheating in this course. It'll really screw you if you try and cheat in this course. And I know that sounds harsh, but like, you're not just going to get a 0, like we're going to the head of the department or the dean or something. Just do not take advantage of the fact that the courses are online this term. So I got some other questions. Is there a penalty if we do the assignment solo? So the only penalty to doing the assignment solo is that you have to do more work, okay? And the assignments have been designed with 2 people in mind. So please keep that in mind. If you can totally choose to do the assignment solo if you want, but that's up to you. That's like at your own risk. Can I do the final project as an undergrad? I mean, you can do all the extra work you want, but you will not be getting credit for it, okay? Because that's not how the course is being marked this term. Yeah, invisible pixels, we have some of that. Is the project about literature review or programming? The project will be programming. So you will, so the project for the graduate students, right here, the final project, 20%, it'll be in a group of up to 2. This is a typo that I'll fix. The graduate student project, you will do one of 2 things. You're either going to take one of the assignments and go research online a bunch of improvements or data structures or algorithmic enhancements that you can use for that and implement all of those to make a way better assignment. Or you can take an algorithm that we used in the class and apply it to a different game. So for example, one of the things that I recommend, which has been done in the past, is like you take the reinforcement learning algorithm that we did in class, and instead of using the class assignment, you like use it to play a game like blackjack or something like that. Okay, or you could take the A-Search search pathfinding, and when it comes time to actually like worry about the assignment, I have a whole PDF with details about the assignment and sample projects and stuff that I'll give out. So don't worry about that until about, halfway through the course sort of thing. Okay. So if there's any other questions on that, just let me know in the chat, because I'm going to go into a PowerPoint presentation now, this is sort of the what is AI part of the assignment, or part of the first lecture. Okie dokie. So, that's the Discord. Okay. So, and again, for people who weren't here at the beginning, because I think when I said this, there were only about 30 viewers, each lecture will be this, right? So it'll be me talking with the little webcam over slides. You probably hear my chair squeaking a little bit. And the slides, I will go through them on the screen, just like this. And the video, the recording of this, will be put in two places. So the recording, well, actually 3 places if you think about it. So the recording will be left on Twitch or as a VOD, so you can go into my videos and view it there. Or I'll be making a YouTube playlist of all the lectures that you can go back and watch. And third, because there are some people who do not have access to Twitch or YouTube, I will be putting the videos in the lecture section of the website as video files for you to download, okay? So everyone will have access to it. But what I do ask of people is just to save on the university's bandwidth a little bit. If you can view the VODs either on Twitch or on YouTube, please don't download the files. Because if we have like 120 people downloading gigabyte lectures, then that's probably going to be an issue at some point. Okay. So, lecture 1. This is really quick. It's not a full lecture, but we're going to talk about what is AI, AI categories and examples, and just some applications of AI as well. Okay, so here's a quick note. I've already talked, so I got a question. Will you provide the topic of the project? Yes, I will give example topics. All right, so I've already talked about this a little bit, but there is no required textbook for 3200. Oh, and also, just to say, while you see PowerPoint on the screen, I'm going to be pretty much ignoring the chat because it's almost impossible for me to read the slides and the chat at the same time. So I will stop at a particular point and go back and see if there's any questions that I should answer. So there's no required textbook for 3200. And because there's no required textbook, the slides have been designed to be the study material, okay? So typically, when I give presentations and stuff, I don't like there to be lots of text on the slides, but for some lectures, there will be text on the slides. And the reason for that is because the slides will be the thing that you should study, okay? So if you see that there's some slides where I'm just reading the material, of course I'm going to say some extra stuff about it, but if I'm reading the slides, it's because you're also given the slides as the study material. So you should be able to do all the assignments and study for the exams from these slides, okay? Now, it will help you if you go read the reinforcement learning book because it's incredible, but you should be able to do fine in the course just from the lectures, videos, and the slides themselves. So the lectures are a mix of reading from the slides as well as other demos, right? So I'll be giving programming demos, I'll be going over the assignments, just like this on the slides themselves. And one note is that the slides will be given as a PDF just because the PowerPoint versions are kind of large. And so the slides are given as a PDF. So if you ever see animations in the videos, those animations will not show up in the PDF slides. So that's the only difference between the videos and the slides, is that there will be animations. Now, if you can see my mouse here on the screen, you can see that in some slides, there is actually, like my face is covering a little bit of it. But based on the feedback I received, people like seeing the prof, and so I'm going to keep that there and it might cover a couple of words, but you will have access to the PDF. So if there's like a word or two that you missed, then you can go back and look at that later. All right. So what is artificial intelligence? That's the whole point of this course, right? So intelligence is the capacity for learning, reasoning, understanding, or problem solving. You could write entire PhD thesis on what intelligence is. So take it with a grain of salt. If you ask 100 AI researchers what AI is or what intelligence is, you'll probably get 90 different answers, right? So intelligence this is what we're going with. It's you can either learn or reason or problem solve or understand or make a decision in some sort of space. That is sort of the abstract definition of intelligence. So what artificial intelligence is it's building a program or a machine that appears intelligent to the user in some domain, right? So you've built something, you've built a program that within some problem space is intelligent or appears to act intelligent. And appears intelligent is really important because there's a lot of AI systems that appear intelligent and people love them, but actually aren't that intelligent under the hood. And so there's also the idea of sort of a strong or general AI. And what a general AI means is that it's a system that's good at everything, okay? So building a system that's literally good at everything that's the idea of a strong AI. So yeah, I just had an idea, or not an idea, but someone in the chat. Let me try putting this up here and we'll see how that goes, because I think there's less stuff on the top right. That was a good idea. Okay. So, artificial intelligence. The term AI was coined by John McCarthy. He was a very, very famous computer science researcher. He developed Lisp. If you've ever used Lisp, you either love or hate this man. He won the Turing Award, and the Turing Award is like the Nobel Prize for computer science. And he said about AI, it is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence. But AI does not have to confine itself to methods that are biologically observable. Okay? So that last part it's really important. Artificial intelligence does not have to be like human intelligence. Okay? It doesn't have to be like intelligence that exists in nature. But at the same time, in my opinion, AI is kind of an inaccurate term, right? If something is intelligent to me, it's just intelligent. There's nothing artificial about it. And so machine intelligence is probably what it should be called, but AI is such a popular term that we're just calling it AI, right? So AI is the science of making computers do things that require intelligence when done by humans, right? This is another quote that I saw that I really liked. So this is what AI is. If you ask like 100 people on the street what AI is, they might say, like the Terminator or Skynet, but it doesn't have to have anything to do with robotics or human problems or anything like that. It's literally just computers making decisions. That is what AI is. Now, when it comes to AI, there are lots of different areas. Let me see if my pen works here. Does this work? Hey, look at that. That works. Okay, great. Can I undo that? No, I can't undo that. Okay. So we're just going to deal with that now. If you say I'm an AI researcher, right, that is such a huge topic right now. So artificial intelligence covers many, many different algorithms. It covers many, many different problems. And so here's a screen with just some of the most popular fields for AI. So probably the most popular one these days is machine learning, okay? So machine learning, you can do many, many different problems. There's supervised learning, there's unsupervised learning. That is not the topic of this course, so we're not going to get into it. Inside machine learning, you've probably heard of deep learning and neural networks, things like this. We've got predictive analytics. We've got all sorts of things that can happen under the guise of machine learning. Also, we have natural language processing. So natural language processing is a set of algorithms and it's a set of problems, and they're all devoted to things surrounding the problem of human speech, okay? So things like translation. So if you've ever used Google Translate, like that's a natural language processing problem. So you're taking text in one language, translating it to another language. You've also got things like classification and clustering and information extraction. So for example, here's a book, like give an AI a textbook and see what it could learn from that textbook, right? You've also got speech, so things like speech to text and text to speech. How do you analyze those and actually do the translation from in one direction or the other? A particularly old, I say old, it's still around, but like when I did an AI course almost 20 years ago now, expert systems were a big thing. So expert systems are things where you write in a bunch of rules and then you can make derivations based on those rules. So almost like a logic problem. So for example, if you say, like all dogs are brown, all dogs have 4 legs, and this thing has 3 legs, is it a dog, right? Well, if we created the rule that all dogs have 4 legs and it's not. And so it's a really kind of basic early form of AI that would try and make conclusions from rules that you gave it. Here, this is a really important one. So planning, scheduling, and optimization. That is going to be the first half of this course, okay? So this is search. If you've ever heard of like search-based AI, that is planning, scheduling, and optimization. And we'll go in the next couple of lectures, we'll talk about like what search is, why it's called search, heuristic search, all that kind of stuff. Robotics, of course, is a huge field of AI that has all of its own problems, like they're dealing with real-world problems. We won't be dealing with real-world problems in this course. We'll have sort of these game environments that we're going to be dealing with. But robotics has lots of hard problems that it deals with. Also, we have things like computer vision, right? So image recognition, machine vision, feature extraction, facial matching, all those sorts of things are all problems within computer vision. So if you say the term artificial intelligence, it's so big, right? It could mean almost anything in computing these days. And if you've looked at any company's like mission statement or whatever on their website, of course they're going to say that they're using AI for all their things, right? So everyone thinks they're using AI. A lot of people are, but we'll at the end of the course, hopefully you'll know what AI is and be able to use the term correctly. So, does anyone know who this is? Type in the chat if you know who this is while I take a drink. Eisenhower. Nope. There we go. Alan Turing. Okay. It's Turing. So, Alan Turing, the grandfather of computer science, right? Made the first computers, wrote the first papers on computers, developed the modern architecture for computers. Amazing, amazing human being. Some people say that he was instrumental in winning World War II. If you've never seen The Imitation Game, the movie, that's basically a biography about Alan Turing. I won't get into him too much as a person, but Alan Turing is one of my heroes and great computer scientist. So, Alan Turing was considering the problem, can machines think, right? And that's an important problem. Well, important to philosophers at least. And the problem is the definitions of machine and think are both very, very difficult, right? Like, what is a machine? Is the brain a machine? Or is it not because it's grown, right? So what Alan Turing said was the original question, can machines think, I believe to be too meaningless to deserve discussion. And so that's a bit of, hyperbole. But what he wanted to do was, instead of just asking that question and debating it, let's pose that question as a game, okay? And the name of that game is the imitation game. And so the problem Turing came up with, essentially, was you have over here, you're going to have a person, this person C here is a human interrogator, okay? So they're behind some sort of screen or wall, and essentially that person is asking questions. And behind that screen or wall is either a computer or a person, okay? So the idea here is that if you can ask questions or carry on a conversation or whatever the problem is, and if the interrogator cannot tell whether the person answering is either A, a human, or B, a computer, then that has passed the Turing test. Okay? So it was originally called the imitation game, but more colloquially known as the Turing test. So this is kind of the standard interpretation of the imitation game, and it says, can computers exhibit behavior which is indistinguishable from humans? Now, that doesn't mean like in every aspect of life, obviously, because you can kind of tell if a human or a computer is walking around, but in some domain, can you tell whether or not the thing making these decisions or talking to you or answering questions is a human or is it a computer? And versions of this question have actually been asked for like centuries, right? So going back to like the 17th century with Descartes, the philosopher, he was asking like things about automata. So they had, even back in the 1600s and 1500s, they had these automata that they built, which were essentially mechanical, non-electrical robots that could do things like write. Like go on YouTube and type in like autonomous writing boy robot and stuff. It's crazy what they were able to do. So Descartes asked, you know, if this robot that we've built is able to write, is it intelligent? Is it thinking? Diderot in 1700s was asking, for example, if a parrot can repeat what you're saying, is it intelligent, right? If it's saying a sentence in English, does that make it intelligent? And Ayer talked about the consciousness of machines, and so this isn't a philosophy course. I'm not going to go any deeper into that, but it's, you know, just to show you that this question has been asked for a long time, and there's no singular answer to this problem. Okay. Here's one other thought experiment that I will go over, though, is John Searle in 1980 posed the original form of this problem, and it's called the Chinese room problem. And it doesn't have to be Chinese, that's just the name that he gave it. So what's happening in this problem is that there's a box, okay? And this box is completely sealed, it's soundproof, it's vision-proof, it's sealed off from the outside world. On one side, there's an input. And what's happening is there are some symbols or piece of paper or something that gets fed in through this input, okay? You can see a symbol dropping down into this bucket here. And what happens is the person inside this box is getting inputs in one language, okay? Whether that's Chinese or Russian or English or French or whatever, they're getting these symbols in one side. Now, inside, the person has access to a huge book. And in this book is the literal translation from the input language to the output language for all possible symbols, okay? So, what happens is the person on the outside passes in an input in one language, and then the person on the other side gets an output in another language, okay? And so the thought experiment here was that, is this person performing an intelligent task, okay? So to the person on the outside, it looks like this is an intelligent task, right? They're taking symbols that are in one language or a whole sentence or whatever and translating it to another language. And that process, if a person was doing that, you would say that that person at least has some intelligence, right? But if you think about this, by looking up the rules and performing the translation, the person inside the box, they appear to know the language. And they appear intelligent, but they're really just looking up things in a book. And so what John Searle said is that computers, all a computer is doing is looking up symbols in a big book, right? It's taking in an input, it's looking up that symbol in its hardware, and it's passing on another input, right? And so computers don't actually, quote unquote, understand what they're doing. And so this was sort of a reply to the Turing test saying that even if a computer exhibits or appears intelligent, it looks like it's intelligent, but it's actually not being intelligent, right? Because it doesn't have this human or biological sort of idea of what intelligence is. Now, my opinion is that intelligence is just intelligence, and it doesn't matter if it appears intelligence or not. A lot of people appear intelligent to me, right? But maybe they aren't intelligent. So this is just sort of the philosophical side of AI. Really interesting problems to think about, but that's all we're going to think about in the course, right? The rest of the course is going to be more concrete kind of stuff. So, besides what AI is and what you think about intelligence, what can AI actually do? Okay, so let's give some concrete examples of AI in our society that can actually do things. So, the first, type in chat if you've ever used Google Maps, okay? Because I use it on a daily basis, and I don't know how I, as a teenager, navigated around St. John's without Google Maps, because there's no street numbers or anything. It's crazy. So planning and scheduling is the first half of this course, okay? So Google Maps is awesome. Apple Maps might take you into the ocean. We don't know yet. But planning and scheduling is one thing that AI is very, very good at, okay? So you take a map and you translate that image of the map into nodes and vertices, and you can have an algorithm which finds you the shortest path, right? So planning and scheduling is something that's already done. Some people are saying in the chat that they can't find their house without it. You might want to put a big balloon outside your house or something. But planning and scheduling is one topic where AI is really good, really established, and we'll be learning the algorithms. In a couple of months, or I'd say in a month and a half, you'll know how to write the algorithms behind Google Maps. Okay. Autonomous control. So autonomous control is a huge problem. It's got a lot of money invested into it now. When I first made these slides, Tesla wasn't a thing yet, right? So self-driving cars are going to be a thing. They are already a thing. They already exist. They are already safer than humans, and they are a huge problem in AI and robotics. Okay, so autonomous control, AI is hugely important in that field. Also, we have things like image and pattern recognition. So since the at least early 90s, probably into the 80s, every single letter that has ever been sent, the address has been scanned by a computer at a post office, okay? So this problem has been around for a long time, and it's recognizing digits or optical character recognition, or OCR, is a problem that's hugely important and has been studied to death, and there's still a lot of new algorithms coming out for this. So image recognition is a big field of AI. We also have over here we see facial recognition. I am of the viewpoint that facial recognition should not exist. I don't like it, but it is a problem that people put a lot of money and a lot of effort into. I think that its applications for evil are a lot more prevalent than its applications for good. So that is what it is. We'll take the face unlock, but it could also be used to track people and stuff. Anyway, it's a big problem. AI is really good at it, and it's actually better at it than humans. So computers are already better at humans at playing games, at driving, at character recognition, and at facial recognition. Okay. Healthcare. So AI in healthcare is going to be absolutely gigantic in the future. If you're thinking of a possible career choice and you don't know, or you want to, where are jobs going to be? AI for healthcare, definitely. Over here we have robotic surgery. Telesurgery is absolutely huge. We'll have, so Elon Musk, I don't know if people saw this, but Neuralink just gave a presentation about their brain implant chip, where they expect their robot is going to be doing all of the surgeries for that automatically. We also have things here is an example of an image. So this is a brain scan image. I'm not sure if it's an MRI or not, but what people do in the medical field, when you have a brain tumor, they take a scan of your brain, and the doctors are going to prescribe a treatment for you based on the size of the tumor and whether or not it's shrunk or grown. So there are literally thousands of people employed across the world that just look at these images and trace what they think is the brain tumor. And that is a lot of manual work. It's prone to error. It's prone to subjectivity from humans. And so a big field of research in AI is actually doing this automatically. And computers are already better at humans in this field as well. We also have robotics. So over here we have the field of nano robotics or swarm robotics. So swarm robotics is the field where you have many, many dumb robots that can together accomplish a complex task. Over here, we have Boston Dynamics, or as I like to call it, like the beginning of Skynet, right? Where we're, pushing robots with hockey sticks and stuff, and they're going to come back one day and teach us a lesson. But, this is an example of a single intelligent robot that's capable of doing intelligent things. Musical composition. So robots can already compose and play music, and they have done studies. So there are entire conferences devoted to AI musical composition. Okay, this is a funny little video of a band, like a robot band, just playing the instruments, but they actually compose music as well. So if you think that, oh, my job is creative, I'm an artist, AI can't come from my job. Nope, it's coming for creativity as well. So this is Google Deep Dream down here, if you've ever seen this before. This is where it takes like a bunch of different images and puts it together in like really psychedelic ways and creates like nightmare fuel images. Over here, this is called style transfer. It's a sub area of image processing where you can, for example, take an input video. So the video here would be this disco ball. And then you take an input painting or set of paintings by an artist. I'm not sure who this artist is, but it will produce the final video. So it will take this video and apply the artist's style to it, right? And that's such a cool project. We also have things like procedural content generation in games. If you like this, you should take Computer Science 4303 next term. That's Game AI. We'll be talking about this. So you can have AI automatically create content for games, right? So if you've played something like Spelunky or Terraria or Minecraft, you have procedural content generation generating those worlds for you as you play. We also have language processing or translation. Google Translate is absolutely incredible. If you've never used this feature on your phone, you should try it out. So just load up an image or like on your screen of another language, so another text. And then what you do is you point Google Translate's camera at the screen, and it will in real time in the same font translate that text to your screen. It's absolutely incredible. I used it when I was in Japan, and I was actually like able to navigate with it. So it's absolutely awesome. And obviously AI can be used to take over the world, right? So if you've watched any movie that has anything to do with AI, eventually AI takes over the world. So now I joke around about that, but there's a lot of people out there, and there are entire conferences again devoted to like the singularity and AI taking over the world. And if you ask my opinion on that, I think that there are very real dangers of AI, but like for the time being, at least for the next couple of decades, just don't give AI access to the nukes. Don't give it a gun. Like, don't put a gun on a drone and it can't shoot anyone, right? Like, despite what you think, or despite what the layperson thinks, these systems are still programmed to accomplish a specific task. They're not going to go out and all of a sudden be able to replicate themselves automatically. Like, you as programmers should know how bad we are at programming. And so I don't trust programmers to be good enough to create a system like Skynet anytime soon. All right. Also, important to this course is game playing, right? So in the past decade or so, we've basically seen, like, for example, this here is the board game of Go. So DeepMind in 2016 created AlphaGo, which is a program that can beat the world champion at Go. And Go was the last board game, the last really popular board game that humans were still better than computers. So just think about this. 4 years ago, in 2016, was the last time that humans were better than computers at board games. Now, of course, there could be a board game out there that no one has written an algorithm for, but I'm talking about like really popular board games like checkers and Go and chess and shogi and all sorts of things like that. You know, they're board games that humans have been dominating for years, and people thought there's no way humans will ever be better, no way computers will ever be better than humans at Go, but that's already been solved. Over here we have StarCraft, and let me just reload this slide. So StarCraft is actually a field of research that I work in, so writing AI algorithms for StarCraft. I actually did my entire PhD in StarCraft, which was really cool. We can talk about that later. But right now, Google DeepMind currently has the strongest StarCraft AI. It's called AlphaStar. And it's playing at the level of sort of medium-tier human professionals. Okay? So it is, in my opinion, nowhere near the world's best players yet, but it is getting there, right? So how long until we beat the world's best people? I don't know. Maybe years, maybe never. But it's coming for video games, and AI is especially good at things like video games. All right. So how do we make new AI? Okay, so you might think, like, all this seems like magic. How do you go from no AI to new AI, right? How is that process, like, actually conceived, and how do we do that? So this is the whole process of AI research and development. And this is, I'll give you the steps now of how it's done. Of course, there's, when it comes to research, there's having the spark, having the idea. That's something that's, just comes through practice and rigor and reading a lot of the literature, etc. So there's no magic formula for this, but this is sort of the process that you go through. So first, you have to identify a problem or an area to work in. And this usually comes in one of two forms, okay? So when you're talking about AI research, either one of the two is true. One, the first possibility is that you really care about a particular problem. So for example, if you really care about StarCraft, right? I want to make the best AI at StarCraft. So what you do there is you identify a problem, and then you write any algorithm that will solve the problem, okay? The second thing is, I really care about the solution or the algorithm. So you could say, I really care about deep neural nets, right? So you're going to make fundamental changes to deep neural nets and then apply that to different problem spaces. So you either identify a problem or a solution area to work in. Now, second, and most importantly, you do a review of the literature of the existing techniques, okay? You don't just go start doing something, because, and I've seen this happen. Let's say you're a PhD student, okay, and there might be some in the chat out there, or a grad student, and what happens is you think you have a great idea, you implement it, you've got your thesis half written, and then you find a paper from 1997 that did your thesis better than you're doing it. And you have to start all over again, okay? I have literally seen that happen twice in my career, and it really sucks, because in academia, at least, if you do something second, that doesn't matter, right? It doesn't matter if you do something second, because there's no way to prove that you didn't just copy off the person who did it first. So in academic research, coming first is all that matters. You publish the paper first. So you have to review existing things in order to make sure, A, no one has done it before, and B, to get ideas, right? Because there's decades of research from thousands of people, and chances are, if you haven't read anything in the literature, then the idea that you're thinking of has been done before. So make sure you read everything in order to get all those ideas for the new stuff. So after you've read everything, then you develop the new techniques, right? And this is sort of like insert magic here. So you've thought of a new technique, you think it'll work, you develop it. Then you test those new techniques against the current state of the art under some specific controlled circumstances. So for example, if you've developed a new pathfinding algorithm for like Google Maps, what you would do is you'd take the existing Google Maps and you'd take your new Google Maps and you'd test it under some set of circumstances, right? And you'd say, well, my algorithm produces better paths. They're shorter paths, or they use less gas or something like that. Or maybe it takes less time to run. Mine runs in a millisecond and theirs run in 10 milliseconds. So you have to show somehow that your algorithm or your technique is better than the existing technique. And then you apply the new technique to the problem and you're done, right? So once you go through these steps, you identify the problem, do a lit review, develop a new technique, you test the new techniques against the state of the art, and then you apply the new technique to the problem, hopefully in the real world, right? Okay, so how do we test new AI? One way is that we play games, all right? Because games measure intelligence, and this is really cool. So most video games So I just looked over. People are asking questions and stuff. I'll come back after and scroll up and ask or like answer questions from the chat because it's really hard to do that while I'm lecturing. So games measure intelligence, right? If you think about it like a strategy game, for example, other than video games where you actually have to have precision and click on the map, if you think about something like chess or Go, the only thing that matters is the strategy, right? Being able to, well, okay, you have to be able to move a piece from one place to the other on the board, but that's kind of trivial, right? Games measure intelligence. And in my opinion, everything is a game. Everything in life is a game. And we'll talk about why. So let's think about it for a second. What is a game? Okay? So in a game, you have some agent in an environment. Okay? That agent can take actions, and the actions affect the environment. That agent has a goal. So the goal might be defeat the opponent. If you're playing Mario, it might be move to the right. If you're playing Sudoku, it might be solve the puzzle. If you're playing like an old school video game, it might be get the most points. Okay? So all you're trying to do in a game is maximize some sort of function. Okay? So that's like a lot of things in real life, right? You're trying to solve a particular problem. Maybe you have to, I don't know, trivial problem like washing the dishes, or a hard problem like stay alive for the longest, right? You're trying to come up with decisions that accomplish your goal in life. So AI in games. Games can simulate what? So why do we use AI in games? Why are games such a good test bed? Well, there's a number of reasons that I just talked about, but I'm also going to mention these. So games can be used as simulators for the real world, okay? So what that means is that if you've got something like, let me give you a concrete example. So there's this hacker named GeoHot, and you can go like Google like GeoHot GTA 4 or something like that. So GeoHot used deep neural nets to learn how to drive in Grand Theft Auto 4 based on the screen, right? So just the screen image data. And then when he had learned, like the algorithm had learned how to drive in the game, he took the same algorithm with no changes and then put it in a real car, and it was able to drive around his neighborhood. Okay, so that's like a really good example of that. And those type of examples exist all over the place. So success in games sometimes translates to the real world. Not always, but sometimes. A big thing for researchers, especially for graduate students and stuff, is that you don't have to fill out ethics requirement for games, right? Like if you're a biology researcher and you're researching a new vaccine, for example, you're going to spend a lot of your time as like the principal researcher filling out ethics forms and like proving to the government or whoever that you're not going to be hurting any animals or whatever. But you can kill all the video game characters you want, right? It doesn't matter. So no ethics are required to actually do learning in video games. They're cheap, right? So for example, in a lab that I worked in once, the robot that we used was $150,000. And it wasn't even close to the top of the line robot at the time. And so robots, like real world stuff, is extremely expensive. If you want to do self-driving cars in the real world, you have to buy a real world car, right? That's going to be a lot of money. Video games are cheap. You can go buy GTA for like $50 or whatever it is. They're easy to visualize. They're really intuitive. Like, for example, if you write an AI that plays Super Mario, right? You can show that to someone who just knows what Mario is. You can show that to the average person and they can appreciate your research, right? Because the AI will be playing this game in an interesting way. So it's really easy to visualize and it's super intuitive. And in a lot of fields of research that aren't AI in games, it's actually difficult for the general public or your funding people to actually get why this problem is important, right? So if you show, for example, some mathematical problem about graph coloring or something like that, like, you know, would your parents be able to understand why that's an important problem? And also, it's really fun to program them and play, right? So I find it fun. Maybe you find it fun. Maybe by the end of the course, you won't find it so fun. But I have found that, you know, it really helps people be motivated and learn the topic when you can actually apply some games to things. And of course, there's always this sort of struggle with AI researchers of like humans versus machines. And so here, for example, if you think about different games, like chess, I think it was 97. Oh my God, I can't write with a mouse. That Garry Kasparov was defeated by Deep Blue. And so humans have been beaten by computers in chess since 97. Checkers was solved. So Jonathan Schaefer at the University of Alberta literally solved checkers. And that means that he has a big database somewhere of if this is the current board state for a game of checkers, what's the optimal move? So you obviously can't have a human do that. So checkers has been solved. Deep neural networks combined with Monte Carlo tree search in 2016. Ooh, there we go. Have been better at the at Go than the world champion, and we're kind of getting close for StarCraft, but we don't know that yet, right? Not only that, like there's interesting problems, but if all you're doing is making video games better, that has a huge tangible economic benefit, right? Like video games, the revenue spent on video games in the past 5 or 10 years is larger than movies and music combined, okay? So this is a huge industrial impact if you make better AI for video games. So just some of the benefits of game AI. You have better in-game AI, right? So that's good. You have more intelligent NPCs. Maybe you have a better single-player experience, so you sell more copies of your game, right? That's always good. Also, you could do something like create offline tools. So this is actually where my research is going now. So for example, let's say you had a really good AI for your game. You can do things like game balancing. Like if we have a world champion AI for StarCraft, then what you can do is play millions and millions of games in StarCraft and say, oh look, this unit for this race is actually completely overpowered, right? And so in that way, your company can save money, you can reduce human testing, and maybe there's not going to be so much crunch time, etc. And then you can apply these to all sorts of areas in the game. So really quick, I'm just going to go over some of the stuff that we do at MUN. Okay, so AI at MUN, like what sort of research is happening at MUN. So I run the AI and Games Lab at MUN, and for those of you who might not be a student, MUN is Memorial University of Newfoundland. That's where I'm working and teaching, and that's where this course is being held. So, you know, these are our funding and stuff. We've had a lot of different grad students. This is the AI lab here. And so here we have some current research projects that we're doing. There's a StarCraft AI competition. Oh yeah, so on the right here, this is our TA for the course. One of our TAs for the course. That's Critch in the chat, so you know who he is now. Some of our current research projects. So every year, there's an international StarCraft AI competition that is held at MUN in our lab. And I've been running that competition since 2010. I run it with another one of my grad students, Richard Kelly, and it's been held at MUN since 2016. There are 2 other competitions, but we won't talk about that right now. And, you know, people from all over the world compete in these things. We've got cool sponsors from industry. We're doing projects like autonomous robotics, reinforcement learning, automatic pattern formation. We write like really cool physics simulators. So for example, here's a particle simulator that we have, and we can use this to do things like reinforcement learning for pattern formation and stuff like this. All sorts of really cool things. So for example, here is a virtual robot learning to form donuts out of little tiny hockey pucks, for example. And it's doing this using reinforcement learning. We also do things like real-time strategy game combat algorithms. So real-time strategy game is a really interesting problem. So I wrote a simulator for StarCraft that we can use to do combat algorithms for StarCraft. We have, so one of the other grad students, Rick, is doing research in machine learning for StarCraft 2. So here we just have a little video of the StarCraft 2 machine learning environment, which translates the game into these like neural net image features that you can use for that. We have research going on AI for video game development and design. So you can do things like pathfinding, you can do procedural content generation. And we also have lots of different courses at MUN that do video games and AI. So for example, we have this course 3200, which is the Intro to AI or Algorithmic Techniques for AI. We have 3201, which is nature-inspired computing. So this is where you get into more things like neural nets, etc. We have 3202, which is Intro to Machine Learning. That's an awesome course. So if you really like machine learning, you should take that one. We have 4300. That's Intro to Game Programming. So that's the other course that I'm teaching this year. That lecture is also on this channel starting at 2 p.m. In, I guess, two and a half hours around then. And we also have 4303. This is offered in the winter semester, and that's AI and computer games. And that was offered for the first time last term. And so, for example, the final project in this course, we had people writing StarCraft bots last year. So that's a cool course as well. All right. So we're going to go back to the lab now for a second. So that's the end of the lecture here. What I'm going to do now is I'm going to go back through the chat a little bit, and I'm going to answer some of the questions that I saw. So for anyone who's like, what the hell is this? Just give me 1 second. So this is the senior lab in our department. And so I know it's creepy, but I hacked the lab, right? So I got to do this. I have other stuff coming. So let's see. Let's scroll up a bit. Anyone doing anything for fighting games yet? So yes, Gaggles Mats. There has been AI for fighting games. So here's the issue: is that even though fighting games are incredibly strategic, when computers have unlimited actions per second, like if they can, perfectly time blocking or perfectly time counterattacking and stuff, then they're just like trivially amazing at the game. And so when it comes to fighting games, you've got to kind of change the problem in order for it to be an interesting AI solution, right? So, yes, AI has already been developed that is superhuman for fighting games. But, yeah. I got a question. Do we need the same partner for every assignment, or can we have different or no partners for other assignments? So it's up to you, okay? You do not have to have the same partner. You absolutely don't have to have a partner at all, but I would really recommend having a partner. A lot of these assignments are tricky, okay? And what's going to happen, like if you are a third-year student, these are going to be probably by far the hardest assignments that you've done so far. But my opinion is that by beating you over the head with programming all term, you're going to come out of this course a better programmer, and you'll be able to do this. And yeah, so never thought I'd hear a professor address students by Twitch ID. So yeah, I want to make sure that you don't have to, you're never going to be forced to say your real name in Twitch. If you want to, you can, but I'll refer to people by the Twitch ID. Would be a better programmer if we solo the assignments? I don't know. I personally believe, so here's a little bit of life advice, okay? So if you go online and you watch like YouTube videos and read articles about what are the skills that I should have going into the job market, right? As a new programmer, you would probably expect that answer to be object-oriented programming, C++, Java, like technical skills. But the most important skill that you could possibly learn going into a job is how to work with people, okay? Because you are going to a company that has dozens or hundreds of other people. You are going to be constantly shifted around in different teams. You're going to be like, oh, hang on. Let me get a different scene up here, okay? I'm going to go to the beach, all right? So you're going to be moved around different teams. You're going to be like working on different topics. You're going to be learning new technologies all the time. And so honestly, this is not like just a meme. You want to learn how to work with people. If you can get that skill before you go into the job industry, okay, that is a very important skill to have. And so if you're thinking that you are like really benefiting yourself by doing these assignments on your own, then that is that is not true, and here's another thing that's kind of ironic, is that you can never know if advice is good advice until the event occurs in which that advice would be needed. Okay? So you can listen to me and say, oh, he doesn't know what he's talking about, I don't need to work with other people, I can get by myself. And so you don't have the experience yet to know if what I'm saying is true or not. Well, please trust me. If you work with people in this course, you'll get really, really good experience. And not only that, but the assignments will be easier. And what I was trying to say earlier was that there's a lot of little tricky stuff. There might be tricky syntax or tricky parts of an algorithm. And if you can show that to another person and you can work together and talk it out, then that is going to make the assignments way easier. So it's not the fact that like there's so much typing or so much code that you're going to need two people to type it, right? It's that you're going to have really tricky things that you have to figure out. And being able to talk to someone else is, you want to do that. Now, here's what you can't do, okay? Do not work by yourself. If you have two people who worked independently on their own assignments, don't talk to each other, okay? Because that's cheating, right? If you're solo and someone else is solo, you cannot hand in two separate assignments. If you're talking to someone else about an assignment and you're both solo, just submit one assignment. Why are you doing double the work, right? So there you go. Let me scroll up. I had a couple of other questions here I didn't get to. There we go. Okay, I'll change this up again. I've got scenes. I've got content for days. Oh, okay, so here we go. Here's a business meeting. So someone asked where the ferrets were. If people don't know by now, I have ferrets as pets, so they'll be popping up in some of the lectures. And if you didn't know, the hidden joke behind this scene is that a group of ferrets is called a business. Okay, so this is a business meeting. And if there's no more questions, I'm getting kind of hungry. Thank you for tuning into the first lecture. I'm going to take off. If you're interested in game programming, then we do have the Intro to Game Programming course. Yeah, this is one ferret, but there'll be other ones that make their appearance. And this lecture will be posted, okay, on D2L. So I'll have it's going to be on the course website. There'll be a link on the course website in one of the folders, in the lectures folder, to all the folders. Again, let me just post this up on the screen. How am I going to do this? Oh, I know. Here's how I'll do this. Okay, so here's the info over here, okay? So every Tuesday and Thursday are the lectures. This is Newfoundland time, if you're unsure. And 2 o'clock to 3:15 is when the game programming lectures are. So hopefully you enjoyed it. I've got lots more scenes, hopefully to keep this interesting. Yeah, I don't have an outro yet. We'll do all of that eventually. But this lecture will be posted online, and thank you all for tuning in, and see you on Tuesday.